Welcome to another new lecture with a new topic. Today's topic is physico-chemical properties of milk. Earlier we have discussed about the composition and nutritive value of milk. Today we will understand the physico-chemical properties of milk in two different parts. Today is the first part. This is both for undergraduate and postgraduate students, and the second part will be mainly for the postgraduate students. So in this topic we will understand different physical and chemical properties like pH, acidity and other color, flavor, oxidation reduction potential, and all these very common and important properties, and some of the less common properties we will discuss in the second lecture. So here is the list of physico-chemical properties of milk like color and appearance, taste, smell, density, specific gravity of milk, acid-base equilibria, boiling point, freezing point, viscosity, refractive index, surface tension, oxidation reduction potential, electrical conductivity, adhesiveness of milk, cream rising, foaming. So these are a list of physicochemical properties, of which the most important and commons I am going to discuss today, and the remainings will be discussed separately in the second part. So here I want to discuss about the importance of these properties, these physicochemical properties. So firstly, it helps in detection of adulteration. As we all know, different kind of adulterants are used in the milk. So for their determination, understanding of some of these properties helps us to detect. Secondly, helps in determining quality of milk. So there are different aspects of quality like physico-chemical quality, microbiological quality, sensory quality. So these quality parameters helps us to determine or to understand any deviation from the quality which is fixed through different kind of standards. Like nowadays FSSAI, they have specific standard for different kind of milk and milk products. It helps in processing of milk and milk products. So we must know some of the quality aspect, particularly the physical or chemical aspect, then only we can use the milk for processing. So for example, if the milk has got more acidity, then it is not very suitable for heat processing. So that acidity we need to determine. That is one of the chemical property, or we can do it through pH also. It helps in evaluating physical changes in milk and milk products during processing. So when we process the milk, there can be several changes. So those changes also we can understand only if we know about the properties of this milk. So here we will understand the physical state of milk. So before we go to understand the properties of milk, we should understand the state of milk, that is different constituents, how they are present. So as we all know, water is the major part in milk. So water is the in continuous phase, and other constituents are either dissolved, suspended or emulsified form. So other major constituents are either in solution form or in emulsion form, or sometimes is in colloidal suspension. So in solution form, the major is lactose, that is the milk sugar, which is a disaccharide, and most of the mineral salt, they are in solution form, and part of the albumin and globulin. Albumin and globulin, as we have seen earlier, they are the whey protein, so mostly they will go with the whey, but much of it is in the solution form, that's why it goes with the whey. Then in colloidal suspension, that is mostly the protein. The major protein is the casein, so which is normally present as calcium caseinate or sometimes as calcium caseinate phosphate. So this protein is mostly in colloidal suspension, and part of the albumin and globulin also will be in the colloidal suspension. And the another third major constituent, that is the fat, and fat is present in the milk in the form of emulsion. So that's why when we separate the milk, we should be very careful, otherwise it will break. And further, when we make butter etc., that emulsion is broken and then the fat is accumulated as lump. So though we are telling physico-chemical properties, but they are not really possible to exactly delineate with which is physical and which is chemical. They are intermixing type. So first we will talk some of the more related like chemical properties. The first one is chemical reaction. Freshly drawn milk normally shows an amphoteric reaction. That means it is neither acidic nor alkaline. So this is due to the presence of amino acids which are amphoteric in nature. That is, amino acids behave both side like acid or alkali because of the formation of Juiter ion. That is, one side there will be carboxylic group acidic and another side there will be ammonium as positive group. So as you might have studied in biochemistry. So that's why milk sometime it will be acidic or amphoteric in normal litmus paper's taste. Then another property that is buffering action. Fresh milk acts as complex buffer, and that is by carbon dioxide, proteins, phosphates and citrates are responsible for this buffering action. This is important for curdling and heat stability. So to a certain extent, when there is a little bit of acidity or when there is little bit of heat, this buffering action protects the milk constituents and prevents the curdling. Now we will understand about acidity of milk. So though we said that it is amphoteric, but generally it will show some kind of acidity. So on titration that is visible. So on titration milk shows certain acidity which is called titratable acidity or TA. Sometimes it is also called as natural acidity or apparent acidity. So this is naturally there with the milk, that's why it is called natural acidity. So this natural acidity is mainly due to the casein, that is the major protein. Sometimes it is present as phosphate or other phosphate compounds and citrates and dissolved carbon dioxide. So these components are responsible for this acidity. Natural acidity of individual milk samples varies due to species. So different species will have some difference in the acidity, and with the breed, even with the individual animal because of their individual physiological differences, or sometime due to different stage of lactation, or sometime due to certain infection in udder, especially mastitis, as you know. The developed or real acidity, that is a new acidity develops in the milk when it is stored and when there is bacterial growth. So that time the lactose is converted to lactic acid, and that is due to the bacterial action. So that time the more acidity comes. So that acidity is called developed acidity or real acidity. So in continuation of acidity of milk, as we have seen earlier, the fat content and SNF content, that is the solid not fat. The other solids which present in the milk other than the fat, those are called solid not fat. So if this solid not fat content is higher, then the natural acidity will be more. If the solid not content fat is lower, then the natural acidity will be less. Now, as I said earlier, the titratable acidity in case of stored milk, if we hold the milk for some time, then the titratable acidity if we get, that includes both the natural acidity and developed acidity. Natural acidity which is already there due to the constituents of milk, and the developed acidity which is due to the bacterial action over the lactose and production of lactic acid. So titratable acidity usually expressed as percent of lactic acid, and these normal values are very important, which is useful for quality assessment and also for deciding the processing ability of milk, etc., which I told at the beginning. In case of cow milk, the titratable acidity is 0.13 to 0.14%, whereas in case of buffalo milk, titratable acidity is 0.14 to 0.15%. So this higher titratable acidity in buffalo milk is mainly due to the higher SNF content. Now we will talk about the pH of milk. Perhaps you remember what is pH. It is the negative logarithm of hydrogen ion concentration in a solution. So if the hydrogen ion concentration is more, then it will give a more value, and that shows more acidic, so pH will be lower. Generally there is a scale of 1 to 14. 7 is at the middle and neutral, so below 7 it goes towards more acidity, and above 7 it goes towards more alkalinity. So in case of milk, as we have discussed about acidity, so that is expressed by pH. So normal fresh cow milk, it is 6.4 to 6.6, and in case of normal buffalo milk, it is 6.7 to 6.8. Higher pH of fresh milk indicates udder infection. That is, I told the mastitis, so that time the pH will be higher, the acidity will be less. Lower pH values indicates bacterial action. As we have seen previously, due to the bacterial action, lactose get converted to lactic acid, so acidity becomes more. So naturally the pH will be at lower side. pH sometime can be above 7 due to this udder infection or other cause. So that time the milk will have abnormal odor or taste or poor heat stability. Of course, the lower pH also, when there is acidic pH or due to bacterial action, when there is formation of lactic acid, the pH goes down. That time, of course, such milk is not suitable for heat processing, so because it has got poor heat stability. Now we will learn about another chemical property, that is oxidation reduction potential. That is the ability to oxidize or reduce. In common sense, it is uptake or loss of oxygen and hydrogen atom. More accurately, it is the uptake or loss of electron. So it is the state in which whether it can take or give the electron. The potential difference of a solution reflect oxidizing or reducing capacity, and that is called as oxidation reduction potential or sometimes redox potential, and it is sometimes designated as EH. Heat, bacterial activity and some trace metal like copper affect the EH of milk. Now there are certain tests for milk like MBRT, methylene blue reduction test, which is used for rough assessment of bacterial quality or bacterial load in milk. Similarly, there is another test called Risa urine test, which is based on this EH reduction. This reduction is because of the use of available oxygen by bacteria. So when the bacterial growth happens, the load increases, and that will utilize the dissolved oxygen in milk. Then there will be a reduction in the EH value or oxidation reduction potential. So on that basis, we do the milk test like MBRT or Risa urine test. So we see how much time is required to get reduced, and it is reflected through some color change. Here we will learn little more about oxidation reduction potential of milk. In case of fresh milk, the normal value ranges between plus 0.2 to plus 0.3 volt. Now heating of milk removes oxygen and thereby decreases oxidation reduction potential. As I told in the previous slide, the oxygen dissolved in milk, that gives the positive value. So when we heat the milk, some of this dissolved oxygen goes out and the ORP goes down. In case of fresh cow milk at 30 degrees Celsius, the exact value is plus 0.258. Whereas in case of fresh buffalo milk at 30 degree, it is plus 0.312 volt. Now in case of methylene blue reduction test, as I said, MBRT, the reduction of methylene blue starts at 0.12 to 0.03 volt. And in case of Risa urine reduction test, it starts at 0.18 to 0.09 volt. But when it goes down slowly, it can reach even at negative value. So that shows a very low ORP value or EH value. Now we will learn about density and specific gravity of milk. This is more a physical property. So density, as you all know, this is the mass per unit volume of any substance. Whereas specific gravity is actually a ratio of density. So ratio of density means density of any substance and with that of a ratio of a standard substance. So generally water is taken as standard and the value of water is 1. The density value of water is 1. So the ratio will be always same as the density. That's why the value of density and specific gravity of any substance will be same. Only the unit will not be there in case of specific gravity. The specific gravity of milk is usually taken at a standard temperature, that is 15.6 degrees Celsius, and milk is having a higher specific gravity than water. That is because of the so many constituents present in milk and particularly the dissolved substances. The weight of a known volume can be determined with an instrument called pycnometer or hydrostatic balance, whereas we can do other way. The volume of known weight we can do with the help of lactometer. So lactometer is a specific instrument which is used for directly measuring the specific gravity of milk. So it has got a specific weight. On that basis it replaces a particular volume required for that, through which the result is expressed. Next we will see the specific gravity values for different kind of milk or milk components. So here we will see the specific gravity of milk. This particular parameter is very important in case of real application, particularly related to different kind of adulteration. So in case of normal cow milk it is 1.028 to 1.030. In case of buffalo milk 1.030 to 1.032. And if we see only skim milk where the fat is removed, that is called skim milk, there the specific gravity will be 1.035 to 1.037. If we see fat alone, milk fat alone, the specific gravity will be 0.93. That is a very lightweight, so that's why it is less than 1. In case of protein it is quite high, so particularly the casein, the specific gravity will be 1.346. If we take lactose, even still higher, it is 1.666. If we take SNF altogether other than the fat, then it is 1.616. If we take minerals alone as salts, then the specific gravity 4.12. So this gives an idea about the specific gravity of milk or different components. Then specific gravity of milk is lowered by addition of water and cream. So we all know many times the vendor can add water for benefit. So when the water is added, then specific gravity will go down, so that we can easily detect by using the lactometer. Similarly, if we add cream, because cream has a lower specific gravity, so if we add cream, then the specific gravity will go down. Whereas it is increased by the addition of skim milk. So if skim milk we add, because it has a higher specific gravity than the whole milk, so the specific gravity will increase. Or sometime we remove the fat for our benefit, then the specific gravity will increase. So here we will learn another important property of milk, that is freezing point. So this is more of a physical property. So freezing point means it is a temperature at which a liquid start freezing or getting solid, started to become solid. That particular temperature is called freezing point. So in case of water, especially at 4 degrees Celsius, the freezing point is 0 degree. But whereas in any other solution, it will be lower. So a solution freezes at a lower temperature than the pure solvent. So pure water 0 degree, but when it is having any soluble items, then it will be lower than that. So milk has lower freezing point than water due to the presence of lactose and salts in solution phase. The freezing point is affected by increased acidity. So as I said, due to bacterial growth, there will be lactic acid. So acidity increases. That time the freezing point will go down. Even with the addition of preservatives, it will go down. Addition of water will increase the freezing point. When we add the water, then the concentration of soluble items will be less. So the freezing point will increase. During detection of adulteration by water, a small difference in freezing point of 0.01 degrees Celsius corresponds to almost 2% added water. So if we add the water, the concentration of solutes will be less, so the freezing point will go up, and that is used also for detection of adulteration by checking the freezing point. So here we will see the average freezing point of different milk. In case of cow milk, it is minus 0.555. So it is below 0. In case of buffalo milk, it is minus 0.560. This is little more down because it has got more soluble substance or more SNF. In case of goat milk, minus 0.575, and in case of sheep milk, minus 0.588 degree Celsius. So generally this freezing point goes down. That is measured as freezing point depression, which we will discuss in more details in the second part of this topic. Now we will see another physical property of milk, that is boiling point. So boiling point is a temperature at which a liquid starts boiling. So that temperature is called boiling point. In case of pure water, the boiling point is 100 degrees Celsius at normal atmospheric pressure, and in case of any other solution, that boiling point will be higher because of the presence of solutes. So milk is slightly heavier than water because of the presence of solutes. So naturally it will have a higher boiling point. So boiling point of a liquid is influenced by factors responsible for its specific gravity. So whatever increases the specific gravity or density, that will have the influence on the boiling point. So milk constituents are responsible for higher boiling point of milk above 100 degrees Celsius. Generally, the boiling point is 100.15 degrees Celsius. The boiling point of cow and buffalo milk ranges between 100.2 to 102 degrees Celsius. Now we will learn another important physical property, that is color of milk. So color is a blend of the individual effects produced by dispersion of light by fat globules, colloids of casein, and calcium phosphate. So generally in case of cow milk, it is yellowish white, but that of buffalo, sheep, goat and other species, it is more white. So there is carotene is the major pigment in cow milk, which imparts the yellowish tint, whereas in case of buffalo milk, this carotene get converted to vitamin A due to the presence of carotenase enzyme. So that's why the buffalo milk is mostly white, or even other species. The bluish color of skim milk or whey is due to the another pigment, that is riboflavin, which is also called vitamin B2 or lactochrome. So this is briefly about the color, and we will see little more in the next. So here we will see the color of milk of different species. In case of cow milk, it is yellowish creamy. As I said, it is mainly due to the presence of pigment carotene or beta carotene, whereas in case of buffalo milk, it is more white because the carotene is converted to vitamin A due to the particular enzyme present in buffalo. In case of skim milk, it is bluish white. This is mainly due to the riboflavin pigment, and in case of whey, it is more of greenish yellow color. Again, it is due to the riboflavin. Here we will see some of the factors which determines the color of milk, especially the yellow color in cow milk. So that depends on breed, feeds, size of fat globules and fat percent. So what kind of feed is given, that has an important role, the size of fat globules and the fat percent. So carotene content in cow milk, it is about 30 microgram per gram, whereas in case of buffalo milk, it is very low, 0.25 to 0.48 microgram per gram. So greater the intake of green feed, deeper the yellow color. So this carotene is synthesized due to the green feeds. Then larger the fat globules and higher the fat percent, yellow color will be deeper. So this is particularly in case of cow milk. And skim milk, Greenish tint is due to riboflavin, which I have already told. Now we will understand the another important physical property, the flavor of milk. This is the last one in this part 1. So flavor is actually the combination of taste and smell. Sometimes it is discussed separately for taste and smell, but here I want to discuss it together. So milk has got a characteristic mild, pleasant flavor. And this pleasing flavor of milk cannot be duplicated by other fats. The taste of milk is a blend of sweet taste of lactose and salty taste of minerals, and also protein has got a role on this. The phospholipids, the fatty acids and the fat of milk also contributes to this flavor. So cooked flavor of heated milk, often we have got a very good cooked flavor of heated milk or boiled milk, that is mainly due to the formation of a compound called sulfhydryl. When milk is exposed to sunlight for long period, it undergoes a oxidation and produce a oxidized flavor. Here in the we will learn some of the factors of flavor of milk or some of the deviation of milk. So some of the factors like type of feed, as I said, what kind of feed we are giving, that has a influence on the flavor of milk, or sometimes it can create a negative impact. Then season, like winter, summer or rainy season, so there is a change in the flavor. Then state of lactation, that is the first part or middle part or second part of lactation, or first coming, second coming, also has got an impact on the flavor of milk. Then condition of udder, so if the udder is healthy or if it is unhealthy or having some infection, it can cause a deviation in the flavor. So earlier we said the lactic acid develops many times due to bacterial growth, and the flavor of milk changes towards characteristic sour odor. So this sour odor is also due to lactic acid and other acids, secondary products like butyric acid or diacetyl. At late lactation, lactose reduces, so the salty taste comes. When the latter part of the lactation, there is a salty taste in the milk. Then udder infection, that is called mastitis, that leads to sometime abnormal taste. Sometimes cows suffering from ketosis, which produces milk with cowy odor, that is mainly due to the ketone bodies produced due to a metabolic disorder in the cow. Now we are at the end of today's lecture. So today we got the physico-chemical properties part 1. Here I have discussed what are the important physico-chemical properties and what is the importance, and some of the chemical properties like acidity, pH, oxidation reduction potential we have discussed, and in the physical properties we have discussed about the specific gravity, the boiling point, the freezing point, and then later we have discussed about the color and flavor of milk. So all these properties are very important to understand and to measure the quality of milk, or for their processing or for adulteration and etc. So these are very important for undergraduate students and also for postgraduate students. And in part 2 I will discuss about the less common properties, that is physico-chemical properties, but they are very important to understand for the postgraduate students. So that I will come back with the part 2.